Hello everyone. In this video, I'm going to talk about background subtraction or subtractor MOG2. There are several background subtraction algorithms in OpenCV, the MOG1, MOG2, GMG, and so on. This is MOG2, and this is by Zivkovic, if I'm not mispronouncing his name. And it is based on Gaussian mixture models, okay, where it is going to basically allow Gaussian models to the foreground and background, and then does segmentation, and then based on that detects foreground and background pixels when it makes the models in each frame, and then it can update basically those models as well. So here I have a video traffic.vi, and I'm gonna read it using CV2 video capture. I make this object CV2 create background subtractor MOG2, so this is creating an object, call it FGBG, and then in a while loop I keep reading the frames from this video. And what I'll do is, I wanted to show you one extra thing that I haven't covered in my previous videos, and that is adding a border or padding frames, right? I said let me add that to this video, make it a little bit more interesting. So here, these frames that I'm reading from that video are very small. I add a little bit frame to them, and I can do that using CV2 copy make border. What you need is you pass to it the frame, and then there are three modes for creating borders. One of them is CV2 border constant. So here you add a border of constant color to the frame. Here my color is blue, and I add the thickness of the border on all sides. Let's make all of the 20. So the thickness of the border on the left, top, bottom, and the right, they are all 20 pixels in this case. So my image is going to be whatever it is, plus a few blue bands on each side. There are other options too. This one is going to reflect those many pixels inside the image. They're going to reflect them on the outer side. So a portion of your image on the edges or near the edges is going to be the reflection of the parts that are a little bit further inside. And this one is going to replicate those many pixels from the edges. It's gonna replicate them. So this is like the simplest one. Those pixels are constant color. These two will use the image pixels themselves and either replicate them or reflect them with respect to the edges. Okay, so for the background subtraction calculations or optical flow calculations, clearly these two are no good, because they're gonna add to the moving objects if the objects are close to the edges, and they're gonna ruin your background and foreground estimations. So here I use the constant, but I'll show you these. They are kind of nice. They add some extra visual effect, I would call, but they are not accurate, so you have to use this constant. And then I apply this foreground background object using the apply method. I apply it to my frame. That is gonna give me the foreground mask, which has foreground in white and background in black. And I'm going to show you in a loop the frame and the foreground detection, and I keep doing it until the key escape is pressed, and then I'm going to release the cap reader and I'm going to destroy all of the windows. So let's go ahead and run it together, and you can see them side by side. There we go. So this is the image, the frames from the video. These are those constant 20 pixel frames, and these are your foreground and background. You see it also detects shadows in a different color. If you see, the shadows are detected in gray. Okay, so it does work just perfect. Let me run it one more time just for us to see, because I really like it and it works relatively fine. Now, of course, it detects a little bit. It has some, this is the lighting changes that happening. Those are the lighting changes, and of course it is going to affect a little bit the performance of the method, but the very white areas, as you can see, they are not big time affected by the lighting or shadow, and they are still considered foreground. Now, if I go ahead and make a mistake and let's say replicate the edges, right, instead of adding a constant color to the edges, that is going to make my frames different and everything else different. So let's take a look at that. See the replicate frame. So you see here, this part is replicated, this part is replicated, a little bit of that 10-20 pixels is replicated on this side. Okay, and look at all of these artifacts that you can see, right? And the more interesting part is when you reflect it, that is even more interesting. So now your edges are reflections, the paddings are reflections of the parts inside the edges. That is make it even more interesting. Look at here. Do you see the reflections? Right? Look at the reflections. So now you're going to see some, look at here. This is the interesting part. Look, right? It's like, as you can see here, right? You see when one car enters the field, it's like another car is going up. So that is giving you that extra artifact. Let's just play it one more time. I really like this one. That is like a visual effect, like you have a mirror or something, right? On the top of the highway or the bottom of the highway. So, but just wanted to show you that we can add paddings, we can add borders to the images, and we can use this method out of several methods to extract foreground and background. So this was a short video. Hopefully it was useful to you, and I'll see you in my next lecture. Thank you.